Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 271. Maximum fruits harvest after at most K steps. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. I thought this was an okay problem. I feel a little bit sad about this during the contest. And so I'm explaining a little bit about the contest and my mindset, because this is just part of how I do these explanations. So I actually solved this in about 17 minutes, which is long. And if you watch, and I do have this portion of the video later on, so you could watch me solve it live. So I had the idea very quickly, but I did spend debugging off by once, or in my case off by two, which is why I took so long to debug. But it took about 9 or 10 minutes to debug this problem. So definitely yeah, and that was a little bit sad. And at the end, I was so not confident that I spent another 3 or 4 minutes just verifying cases by cases. I could have been much higher, but well, a little bit sad, but that's okay. But yeah, so the key part about this problem is just binary search. The first observation that you can make is doing it in a greedy way. And what does that mean, right? That means that at most, you're only going to go left and going right. There's no other ways about it. Like if you think about it because you can only harvest each strawberry once. It doesn't there's no going back and forth doesn't do anything, right? Like, I think this is very intuitive. I don't know. I mean, it is greedy, but I don't know how to have a strict mathematical proof or something like that. I think it's just very intuitive. Like, I mean, on these streams, on these videos, I hate to just be like, oh, it's intuitive, it's obvious, and so forth. But to be honest, like for this one, that's how I feel, right? Like, if you double back and forth, you're wasting a lot of steps. So the best move is always going to be go left and then right, or go right and then left, right? Yeah, I said that a little bit weird. So let's say it again. I go left and then right, and then right and then left. So there are a couple of scenarios, and you have to kind of break them down. But that's basically the idea. And from that observation, it's just binary search. And prefix sums is the way that I did it. Though maybe, yeah, I don't know. I mean, that's the way that I did it, say. But I think maybe you can do some amortized things to do it without prefix sum, but I think that's just way more complicated. I'm not gonna go over that. With like, I mean, it's not way too complicated. Actually, I think you could do something with. Now that I think about it, I didn't do. This is not my code, but you can actually do something with 2 pointers actually. But yeah, so there is a 2-pointer solution, I think, now that I think about it, and you could do it in linear time. But I didn't do it that way, so I'm not going to go. I mean, I'll go over it very briefly about how to do the 2 pointers. And I actually, to be fully honest, that 2-pointer idea just came to my head, so I didn't. Yeah, so I'm not. Yeah. And now that I think about it, maybe if I had just done that, maybe I could have fewer off by once, because that 2 pointers makes more sense. Because I was having off by once by binary search. But anyway, yeah, with that idea, then it is just brute force, in a way, brute force and binary search, right? And what I mean by that is that given a starting point, try to go to every strawberry on the left, and then given that, let's say I go, let's say I'm looking at example 2, right? I have this thing. I'm starting at parent 5. So we brute force. Okay, let's say I'm trying to go from 5 to 0. Well, actually, this one is impossible. So it early quits or whatever, right? Early, like, now, friend, you can't get here. But then let's say it goes to 5, and then next you go, okay, can 5 go to the 4? And then you just do the math of, okay, 5 can go to 4 in 1 step. So then now from 4, you only have 3 steps left, so you go to 7. So that's greedy in that way, right? You brute force and greedy, and from that, the binary search is, okay, you can go to 7, so let's binary search for the 7, and then now get the sum in between, right, of like all the strawberries. And that's basically the idea. And then the next, for example, you go, okay, 5 going to 5, going to left, okay, fine. That you use none of the steps, so then now 5 can go to the 9 on the right side. Of course, that only has 5, 6, and 7 on the strawberry. I'm still looking at this in case you're wondering. Oops. So, and which is obviously fewer because it's just 7 plus 2 plus 4, so that's like 13. And then and you and then going to the right, it doesn't make sense. So or at least like now you do it the other direction, right? Of okay, now let's say we go to the right first. Well, let's start from 5 going to 5. Well, 5 going to 5 on the right side means that going to the left, 5 goes to the 1. That means the strawberry fields of 4 and 5, and then next, let's say 5 go to 6. 5 go to 6 uses 1 step, so you have 3 steps left from 6. So you go to 3 on the left side. So now you have from 3, 4, and 5 and 6, which you add that up. So that's basically the idea. That's the brute force. And binary search is the key, right? From now you have 3 and 6, and now you do binary search to get the indexes and then sum everything in between. And that's basically my idea. And I had a lot of off by ones, to be honest, because for these things I'm always a little bit weaker with versus like binary search that I write directly, because I'm always like thinking about whether I need to be inclusive or exclusive, and then I had to map the index return to this to the prefix one. So and this one had not an off by one, but it had an additional thing, so it's a 1 indexed array. But then I had to so I was really off by 1 in a couple of places, so that's why it took me a long time. But basically this is me going to the left and then right. So this is me going to the left. So leftover is just going to the left side to this thing and how many steps are left. If it's possible to get there, we calculate to the right. We just do a binary search on it, and of course, and this is just basic prefix sum math. I'm not gonna go over prefix sum in this video. It is a Q4, but I have done a lot of prefix sum videos and solutions and so forth, and there are a lot of them to be practiced on Leetcode. So definitely be sure to check that out first, or afterwards, whichever order you like. But yeah, and then here this is the same, except for it is going to the right and then left, right? The numbers are similar. We figure out how to get the index, and then that's pretty much it. And then of course, this is the prefix sum of everything in between, which is all the strawberry is in the middle. And then and then we just take the best of all possible answers, and in a way this is brute force. So and you try every possibility, so that's why the proof is okay. So this is n log n because for every n fruit we do a binary search, or sometimes 2 binary search. The signs are actually intentional, even though it looks like that we call if x is equal to starting position, we actually call it twice, but that's because you can go left and right twice. Oh, sorry, you can go left once and right once, so that's why I did it that way. Even though it looks a little bit awkward, but that was intentional during the moment. So this is going to be n log n time and O of n space for the prefix sum. So one more thing, like I said, let me write this down first. N log n time, O of n space, right? So one more thing that I would say about this one is that like I said, there is a O of n time solution, I believe. I'm thinking about it now, so maybe if I'm wrong, apologies, but it's something that you can explore as homework, maybe see if it's right, see if it's wrong. But the idea is that instead of doing this binary search, what happened? Instead of doing this binary search every time, notice that here in a way we're moving the starting point, so therefore we can also move the right point, right? Like if we're going to the left and then right, we're only moving the left point 1 by 1, and then now we're moving the right point by using binary search to calculate, which is what I do. But actually you could do two pointers, right? You could keep on going to the right, and that's going to be linear time because, well, the right pointer, it's only going to move n times, and the left pointer obviously also going to move n times, and then also the other side, so it's going to be linear time, linear space is what I'm going to say. So definitely try to see if you could do that one. And in retrospect, to be honest, that's what I should have done, because I think it, at least for me and how I would like to write it, I haven't written it, would have been less error prone by off by ones, because it's just like a while loop, right? And the while loop invariant is more obvious to me than like off by one on binary search. But yeah. Anyway. That's all I have for this one. Let me know what you think. This is the top. This is the bottom. It's pretty okay. Yeah, let me know what you think. And you can see all my debugging print statements. Print statements of shame. Anyway, yeah, you could see me solve it live in the contest next, including that super annoying 9-minute debug or whatever it is. So yeah. Anyway, see you in a bit. This one, okay. I was gonna say I'm a little skeptical about that one, but we'll see. Mm-hmm. Hmm. Shouldn't be that bad. Should be binary search somewhere, but okay. Oops. Go left and go right. Okay. It's no, it's this. don't need to. So it's from x plus leftover or that's as far as you can get. And then oh, this is a list. Awkward. This is so possibly typoing. Wait, no, so this one is going from left and right. This is going to right. Go to left. Okay, yeah, that's right. On an index. That's not right. It's maybe off by one though. Yeah, off by a lot even. This is going to the left. Start at 5. This is not right. Maybe. I should have this, but I'm a little bit slow today. That one's a little bit much. Six. So it goes 1. That would be 11 if it's possible. So it goes 1. And then... Okay, this is not right. It doesn't even use leftover. Okay. Penalizing the people who do this. 9, 13, 0. So that's wrong. Okay. Just 13 when it should be 14. So it should go to the 4. On the 4 we have 10 when that should be 14. Why? 3 and 1. So it is 1, 2, 3. So 1, 2, 3, 4 minus 10. Is that right? 1, 2, 3, 4. Here. 19 minus 9, I guess that's right, but this should be plus 1. So I have an off by 1. This syntax is weird. It's 4, but actually, why is it? What is it searching for? Debugging is so expensive. I got most of the ideas, but I'm not doing this right. 4 to the right is 7. Is that right? Yeah, that's right. So why is this giving me? It's giving me. So it should contain 4. I did this thing. Okay, now it's way too big. Why did I have 22? Okay, so this is right. 14. 5 and then 9. Should not be 22, it should be 9, 13. Off by 1's on the binary search. Okay, let's see. So we should go to the right on 9, which is true. So we should just have these 3. Why am I including the 10? Because I'm searching for the 10, and therefore it finds this and be inclusive to it. Oh. Zero. Am I right? Let's see. I mean, might as well spend extra minute debugging. 1 and 8. 1. 5 goes to the. Oh, because it's doing the other one. Okay. It goes to the left side, and it only goes to A. It goes 4, so it goes to 1, and then it goes to 8 because it's these 2. Okay. 6 goes to right, so it goes 1, and it goes all the way to 3. Is that right? 4, 5. 6 minus 3 left. Okay, so that's right. So 3, so it has these 10. Okay. Let's give it a spin. Not confident about this one. Okay, cool. Spent a lot of time confirming that one. Probably could have been faster. Yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord, especially if you like these contests. There's a lot of smart people sharing the beautiful code there, and also me. But yeah, that's what I have. Stay good, stay healthy, to good mental health, take care of yourself, take care of others if you get a chance, and I'll see you later. Bye-bye.